If your electronic device is going to utilize wireless connectivity, you will need an antenna. We'll be discussing the differences between internal and external antennas today, so stay tuned. The difference between an internal and an external antenna is incredibly simple. Internal antennas are inside the device, and external antennas are on the outside. Ta-da! Video over! On a more serious note, as simple as that difference may be, whether the antenna is inside or outside does have different effects on performance, and thus they have separate use cases. Performance-wise, external antennas tend to outperform internal ones. The bandwidth, which is the range of frequencies that your device is intended to operate on, is usually one of the very first things to consider when selecting an antenna. External antennas generally outperform internal antennas on lower bandwidths. So if your device is going to operate on lower frequencies, such as certain LTE bands in the 400 MHz range, it would be much easier to go with an external antenna. Also, because external antennas are on the outside, that alone means they can be bigger in size and have the potential of a stronger performance versus internal antennas.
Hello? Shake, don't cut down that antenna. Give me one good reason.
They get every TV show up here. I mean, even pay-per-view.
Stay there, I'm coming up.
With that being said, it still ultimately depends on how the antenna was designed. In addition to looking at the bandwidth, other parameters to look at when selecting an antenna are the radiation pattern and the gain. These will let you know the antenna's signal strength and whether or not the antenna has a stronger signal when facing a certain direction. Check our blogs in the description below for more details about these parameters, as well as the different types of internal and external antennas. One of the biggest aspects that will determine which antenna you need is the form factor and size of your device. Internal antennas were specifically intended for small electronic devices such as phones and smartwatches. External antennas being outside means that they're not as ideal for portability, and they do have a higher likelihood of damage since they aren't protected on the inside of the device. So devices that get moved around a lot also lean in favor of internal antennas. For instance, a router generally stays in one spot and doesn't really need to be moved around very often. While some router designs may go against the feng shui of certain rooms, for the most part, the form factor of the router isn't a huge consideration, and thus an external antenna is fine for this. On the flip side, smartwatches are very small devices and are always on the go. It isn't ideal to have external antennas hanging off the watch while it's on your wrist, and whether or not it's aesthetically pleasing is an important buying consideration for customers. Thus, an internal antenna is the ideal option for this case. The next big factor is cost. For the most part, internal antennas tend to be cheaper than external antennas, so that's a very big plus in favor of internal. The caveat, however, is that what you save in money, you'll pay for in time and stress. This is because internal antennas require extra design planning and are affected by design variables. Most notably, the size of the PCB board and its ground plane, the available space on the board, other components being too close and affecting performance, and the extensive RF knowledge that's needed to tune and optimize the antenna's performance. Designing around internal antennas can sometimes be like trying to move an image in a Word file and then having the formatting and text of your document turn into a complete mess to the point that you have to readjust the formatting all over again. And even then, it still might not work. For these reasons, internal antennas tend to require a lot more design planning and a lot more testing. And because of this, the ease of integration is the next big factor. External antennas are very user-friendly. Simply plug it into the device and that's it. You usually won't need to worry about design issues like the size or space of the PCB board. You don't need much RF experience, if any, and so the design and testing processes are much faster. That being said, there are many different kinds of internal antennas, and they all have different requirements in terms of PCB needs, RF design, etc. For this reason, when it comes to internal antennas, FPC antennas are extremely common. They're very similar to external antennas since they require much less design effort, and FPC antennas are ground plane independent, which means the size of the PCB it's connected to does not play a factor in their performance, and they're mounted off the board, and thus the size of the PCB area doesn't matter. In fact, many boards from many suppliers come with specific U.FL connectors for FPC antennas. So if you're looking for an FPC antenna, the Taoglas FXUB66 is an internal FPC antenna that covers all working frequencies in the 600 to 6000 MHz spectrum, including all cellular, NB-IoT, Cat-M, Wi-Fi, ISM, and GNSS bands. The FXUB66 features a peak gain of 5 dBi and more than 60% efficiency across all cellular bands, allowing you to future-proof your 5G and 4G devices on a global scale while keeping manufacturing costs down over the lifetime of the product. For more information, check the link in the description below. And that is it. Hopefully this video helped explain some of the key differences between internal and external antennas. And if you still have more questions, feel free to drop us a line. As always, Symmetry Electronics has components in stock, and our engineers are always on standby to offer support for your design. So be sure to contact Symmetry today.